This is our video on how sex drives evolution by Bonilla, Brooke Lopez, and Aris Mazmanian.
Peacocks seem to violate Darwinism due to their traits that make them attractive but also maladaptive for survival. Traits include colorful feathers and long tails. What is the problem with these traits? Colorful feathers attract females as well as predators. Long tails produce aerodynamic problems in flight and makes it harder to escape predators. Also, tails have to be regrown each year and takes a lot of metabolic energy for the males. For example, most of the avian species typically have bright plumage as seen on the image to your left. Strange behaviors can be seen in only one sex. Here we have the male Tangara frogs of Central America. They use their inflatable vocal sacs to sing long serenades each night. Unfortunately, they attract more predators than non-calling females. Traits reduce survival. Several experiments were conducted, but one of the most important experiments was by Jerry Husak and his colleagues at Oklahoma State University. They tested hypotheses that the male lizard's bright colors attracted more predators. In his experiment, he placed clay models painted like the male and female lizards in the desert. 35 out of 40 males were bitten by predators, and none of the females were bitten by the predators. The solution. Darwin was the first to notice a trade-off. He also coined sexual selection. Sexual selection is selection that increases an individual's chance of getting a mate. These traits do not help your survival, but may increase your chances of having an offspring. There are two forms of sexual selection. The first one is direct competition between males for access to females. In direct competition, selection favors any traits that promote such victories as long as it increases the chances of getting more mates. In the second form, females choosiness among possible mates. In females' eyes, not all males are the same, as seen in this figure.
There are various strategies a male can employ in post-mating competition to prevent the female mate from being mated with again within a short time. Here are some examples of this chemical and mechanical weaponry. Male canines have a general knot which keeps the female stuck in place to ensure the ejaculate does not leak out. Similarly, octopi have a plug that prevents near-future penetration from other males and keeps the sperm securely inside the female. Many species have a penile scoop which physically removes competitor ejaculate, as seen in this dragonfly's penis. With regards to pre-mating competition, many marine organisms, represented by these flatworms, engage in penis fetching, which induces a sex change where the individual pierced by the other's penis becomes the female to house the couple's offspring. How is sexual reproduction evolutionarily favorable over asexual reproduction? Well, the sacrifice entails the segregation of a diploid set into haploid gametes as opposed to the preservation of all the favorable alleles if one were to asexually reproduce. Theoretically, asexual cloning would outgrow sexual reproduction within the same species, as seen in the diagram to the right, looking at one sex asexually reproducing than the other, at a steady geometric increase rather than sexual reproduction. Parthenogenesis, an asexual form of reproduction, produces an exact copy of the mother's genes, which conserves genetic information with no cost in mating and is not metabolically taxing. However, sexual reproduction is favored in that it produces faster evolution, with contributions of two different genomes fusing together in syngamy. New adaptive combinations can be made and are also purging bad genes as they may be linked to advantageous ones. These bad genes can be then allocated into a genetic scapegoat which will eventually die off through selection, and this will increase the organism's fitness as a population. A division between two sexes is established by an ecological differential in metabolism. Eggs are a limiting resource, and these eggs take up a lot of energy for the female during pregnancy, in producing them, and in monthly cycles. So overall, the parental investment is mostly supplied by the female in many species and little male support. As such, mating is a more crucial event for females as they have to select a mate and be very careful who they choose to fertilize their egg, as they only have one. proportionally compared to the multitude of sperm males produce. And so, this leads to female preference versus male promiscuity overall. The law of battles states that males are typically the pursuers as they can potentially be related to more offspring than females. They have the ability to sire various number of families with different mates. The direct competition between males is a fight over whose genes are passed into the next generation. This engages males to display elaborate shows for females so that they stick out over competitors and they are selected for it. And these exaggerated characteristics are seen in many avian and insect species, as seen in all these pictures. Here we have an exaggerated chest size, with the bigger the chest, the better the mate, an exaggerated horn, a very colorful display and dance. As opposed to many mating systems where polygamy is prevalent, monogamous species do exist in 2% of mammals. Each parent is given a job in caring for the family, and this system is only possible if monogamy provides benefits to the father when one mate gives him all his offspring and cares for them so his line of genes are passed on securely. Dimorphism is typically the result of two species having competition with the same species. Say if the female were to be in charge of taking care of her brood, then the male has to compete with other males constantly, then they have to assume different forms. If dimorphism is expressed in monogamous species, it is likely that they are only socially monogamous. Individuals maintain one social mate, but over time, come mating season, they do engage in sex with other females or males to increase their brood size. Again, a correlation is seen between dimorphism and the degree of sexual selection in one sex. As seen on different ends of the spectrum, here we have penguins, which are socially monogamous and look the same. But here, in these species of parrots of paradise, they exhibit different phenotypes. The differential pressure affecting each sex differently with respect to environmental pressures, level of sexual competition, and nature of mating strategies employed by each sex, it typically leads to more competition, gives more display. And less competition, most likely a female, they will exhibit less exotic traits as seen in these fairy wren. A male is the blue one and the female is the plain brown one. Further supporting this correlation between dimorphism and the sexual selective pressures, here we have females who exhibit promiscuity and males who are choosy. The reversal of these roles are seen in these species of phalaropes, where the male is very plain compared to the female on the right. And in the sister species to seahorses, the female is very large compared to the male on the bottom. This simply shows the reversal in roles, where the females are polyandrous and will compete for non-pregnant males to store their eggs in. And thusly this drives female ornamentation and exotic display and dances. Males, in this case who are choosy, now select from the wide number of females to mate with and are in charge of parental care for the most part.
Why are females choosy? Darwin's answer was pure aesthetics, which are intrinsically appealing traits to the females. These different features males have would charm and woo the females in order to gain their attention. As for males, they inherit promiscuity. On the left we have a female sage grouse on the top and a male below. The male is promiscuous for it will mate with anything that looks like a female. Most commonly it will mate with a pile of manure. What do females gain? The female is able to gain benefits both directly and indirectly. Directly would be when the male would help the female produce more or healthier young. Indirectly would be when the male has the better genes. This also means the most disease-resistant individuals. For example, this peacock carries a disease which causes it to lack the normal display of feathers. This will prevent him from getting females to choose him. Theory also shows that female choosiness is in favor of males that exhibit traits that show they would be a good father. Genetically superior offspring then come about when these healthy males with good genes mate with females that choose them. The sensory basis model assumes female choice is based on observation of males driven for sexual selection of dimorphism. Pre-existing preferences by natural selection can be co-opted by sexual selection to create new traits in males. In conclusion, sexual traits are selected with respect to female choice and direct competition with other males. These traits lead to dimorphic characters, increased variation, and better response to selective forces.